Okay, we're going to be working quickly here through 21 and 22, so we can do 23, 24 tomorrow. All right, question number 1 says find f of 3 given that f of x equals 3x squared plus 3x plus 12. Essentially, all we're doing at this point is we're plugging 3 in for x. So we get 3 times 3 squared plus 3 times 3 plus 12. So we follow order of operations. We have 3 times 9 plus, I'm going to go ahead and do that, 9 plus 12. We have 27 plus 9 plus 12. Okay, 27 plus 9 is what, 36? 36 plus 12 is 48. Okay, does that work for you guys? Okay, does that all make sense? Okay, because I'm not sure if I have my notes here in front of me or not. Let's see. Here we go. Okay, question number 2. Question number 2 says find f of 330 degrees given 2 cosine x. So we're putting in 330 degrees for x. So 330 degrees. So 2 times cosine of 330 degrees. 330 degrees is right here because it's a positive degree. I'm going around 330, which means my reference angle is 30. I have a 30, 60, 90 triangle. So my ratios here are 1, 2, and radical 3. So the cosine, based upon my reference angle here, is adjacent over hypotenuse. So I get radical 3 over 2. So I have 2 times radical 3 over 2. So my answer is going to be 2 radical 3 divided by 2. My 2's cancel out. I get just radical 3 as an answer. Now, you can also plug this in your graphing calculator. So if you want to do that real quick, make sure you're in degree mode. This is used to test your answer or check it rather than use it to just get your answer. So if I type it in, okay, mode, I'm in degree mode. So 2 cosine 330, right? I get something like this. Now this is why you want to be able to do it, because it's giving you this answer. So what I'm going to do to check my answer is type in radical 3 to see if I get the same decimal. And I do, so I know my radical 3 was correct, right? Okay. All right, so we're going to erase that and move on. These can be a little tricky for people. All I'm doing here is plugging in for x. Okay, but I'm plugging in more than just a value for x, so it's algebraic in a sense. If you've got headphones in, can I make sure that those are out so I've got your attention? All right, so we have 2x squared minus 3x minus 5. What I'm going to do is I'm going to plug in x plus h everywhere where I see an x. Okay, so as I write this, it's 2x plus h squared minus 3 times x plus h minus 5. Okay. I do all the things I would normally do, but notice that x plus h is squared, which means it's not just x squared plus h squared, it's FOILed, right? So what I'm getting there is I'm getting x squared plus 2xh plus h squared. Do I need to do that for you so you see how all that works? Basically, x times x is x squared, x times h is xh, h times x is xh, h times h is h squared. Add up my xh's, I'm getting 2xh, right? Minus, here I'm going to distribute, minus 3x minus 3h minus 5, right? Now I have to distribute this 2, so I have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 5. Okay? Look through, see if I have any like terms that need to be combined. And I'm looking, and I'm not finding anything. And so this is my final answer. Does that make sense? Okay, we're following along. Good. Okay, we're going to take that and complicate it a little bit, not really much. Notice here I want f of x plus h minus f of x. Well, what they tell me is that this is f of x. So I'm going to find f of x plus h, and then I'm going to subtract the original equation from it. Now, whenever I subtract an equation, I have to remember I need to distribute what? The negative, right? I need to distribute that subtraction. So, as I go through here at the beginning, we have x plus h squared plus x plus h minus 5. Okay, well, the more that you do this, the more you begin to see the pattern. X plus h squared is always the same thing. It's always going to be x squared plus 2xh plus h squared plus x plus h minus 5 is what I have there, right? Okay, but I want to subtract f of x. So I want, and granted, I'm going to have to do this down here, minus x squared minus x, right, because I'm distributing the negative, plus 5. Okay? So what you shouldn't, let's see, minus x squared. So what I should see is that x squared minus x squared, those things cancel out. X minus x, that cancels out. Negative 5 plus 5, that cancels out. So what I should be left with is just this, 2xh plus h squared plus x plus h. Hold on, what was this? Was this number 4? Oh, I need to cancel out this x. That's right. So I should just get 2xh plus h squared plus h. Okay? You with me, Ashley? Okay. It would have been helpful if I'd drawn it all out as one single line. It didn't help that it was on 2 different lines. Okay, number 5. We have f of x equals 5 over 2x. We want to find f of x plus h minus f of x. Same scenario, but now we're dealing with division. So we start off with 5 over 2 times x plus h minus f of x. So minus 5 over 2x, right? Now I have two fractions. In order to subtract them, what do I have to have? Common denominator, okay? So when in doubt, multiply both sides by the other side's denominator, correct? Okay. So multiply this over here by 2x plus 2h, because that's what this is, right? Yes? Okay. 2x plus 2h. Oh, multiply all of this by 2x. Okay. Over here, I've got 10x. Let's see. Down on the bottom, it's going to be, because it's 2x plus 2h times 2x, right? I should get what? If I look at this, I should get what? 4x squared? 4x squared plus 4xh, right? Up here I've got 10x, and I'm going to get minus 10x minus 10h, right? Okay. All right, now I need to look for what I can take out of, well, for one, my 10x's are going to cancel, correct? Okay, now I'm going to look for what I can factor out of everything. What can I factor out of everything there? I can factor out 2. Okay, so that's going to leave me with negative 5h over 2x squared plus 2xh. Does that make some sense? Okay. All right. When we get into 6, 7, 6 and 7 is where these get to be a little bit more complicated. We probably don't need to do number 8 because 8, I'm just plugging 2 in. That's just like number 1. All right. I want you to pick one between 6 and 7 because, like I said, we are kind of constrained on time to cover 2 lessons today. 7? 7. Okay, good. All right, so with 7, let's start with understanding this, that we're going to do f of x plus h, then we're going to subtract the equation f of x minus h, and we're going to divide everything by 2h. We're not dividing it by f of 2h or something like that. We're just dividing it by 2h. Okay? All right. Let's see. So we have 2 times x plus h. Okay, that's this x times x plus h minus 4, right? Yes? My handwriting's really too big to make this work, so I'm going to try to write this a little bit smaller. 2 times x plus h times x plus h minus 4. Okay? Now, what we could go ahead and do with that is let's go ahead and simplify it down as much as we can. Let's see, let's go ahead and multiply or distribute the 2. That's going to be 2x plus 2h times x plus h minus 4. Okay? That would be distributive, correct? So what that's going to do, that's going to give me 2x squared plus 2xh, let's see, minus 8x, correct? Okay? That would also give me plus 2xh plus 2h squared minus 8h, right? Okay, is there anything that we can simplify in here? Do I have doubles of anything? Okay, so I just have the 2x squared, right? But I've got 2xh's, so it's going to be plus 4xh. Okay, I don't have any other x's, so I got minus 8x plus 2h squared minus 8h. Correct? Okay, so what I'm going to do at this point is I'm going to erase this top. I'm going to leave what I have here on the bottom that's been reduced, right? And I'm going to find f of x minus h. Yep. All right. F of x minus h. So 2 times x minus h times x minus h minus 4. Okay? So we've got 2x minus 2h. Okay? Times x minus h minus 4. Okay? So we've got 2x squared minus 2xh minus 8x minus 2xh positive 2h squared positive 8h. Right? Okay. Is this really complicated, or just does it look really complicated? Just looks. It's not really anything that we can't do. Okay, so now what we need to understand is that we are subtracting this red one from the blue one, right? Yes? Okay. So as I do that, okay, and I don't really have enough room, but this becomes negative, this becomes positive, 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 negative, negative, right? So I'm taking 2x squared minus 2x squared. What happens? Cancel. Okay? We haven't really simplified this, but that's positive 4xh, correct? Yes? So with a positive 4xh, I should be getting a 8xh, correct? So that's dealing with this, this, and this. I've got positive 8x, negative 8x. What happens there? Cancel. Okay. I've got positive 2h squared and positive 2h squared. What's that going to give me? Positive 4h squared. All right, so we kept that, kept that. All right, I've got negative 8h and negative 8h. Negative 16h. Okay, and I want to divide the whole thing by 2h, right? Okay, so what can I factor out of everything? 2 and h. Okay, let's see if I can try to drag this down a little bit, give you a final answer. So I should get 4x plus 2h minus 8, right? What was this? Was this 6? No, this was 7. I think I missed somewhere where my, what did I miss? I missed, that h squared shouldn't end up being there. It should have canceled out. Did I miss?
The top one is a negative 2h.
The red one? Oh, right here, that's a negative, right? And those should have canceled out here and here, which would have eliminated that. So I should be getting just 4x minus 8. Sorry. 4x minus 8. Okay. Oh. All right. Let's keep going. Domain of a function. Okay. Domain of a function refers to x values. So what we're going to talk about is extraneous values, or values that we can't have. Okay? When I'm dealing with a square root and just a square root, my rule is that it cannot be negative. I cannot have a negative square root, which means whenever I'm looking at this, 3x minus 8 has to be greater than or equal to 0. Does that make sense? Because anything less than 0 is negative. Okay, so we add 8. We get 3x is greater than or equal to 8. Divide by 3. So we get x is greater than or equal to 8/3. Okay, that is my domain. Okay, what are we at here on 9 or 8? 9. Yeah. So the way we write this is we say x is a set of all real values such that. So that's how we write the domain. X is a set of all real values such that x has to be greater than or equal to 8/3. That's how we write the domain. Do we understand? Yes or no? Okay. All right. So you need to remember rule number 1 for domain is that no negatives in a square root. Okay? Rule number 2 is no zeros in the denominator. Why? Because I can't divide by 0. Okay? So that's what applies whenever we look at 10 and 11. I have to work out both of those rules. So I start with the numerator. X minus 8 has to be greater than or equal to what? 0. So x has to be greater than or equal to 8, correct? Now on the bottom, because x can't equal 0, I need to solve for my zeros. Okay? Because it's minus plus, I should be getting minus minus, right? We know that by now. Okay? So 6 and 8, I need things that multiply to be 8 add up to 6. 2 and 4. Okay, 2 and 4. So x would be 2 or 4, correct? Okay, so whenever x is 2, it would cause it to be 0. When x is 4, it would cause it to be 0. But the numerator takes the lead. Okay, because x has to be greater than or equal to 8, I don't have to include those scenarios. Do you follow me? All right, so x is a set of all real values such that x is greater than or equal to 8. Okay? And that should have been 10. Okay, good. because those bottom two aren't necessary. If they were necessary, we would say x cannot equal 2 or 8. All right, from here, oh gosh, what is this? 12, domain and range. We're talking about x and y values. So you're looking at open circles, closed circles, right? Top and bottom. So x is left or right, how far we go left or right. Y is how far we go up and down. Okay, so as we look at number 12, our domain, x is a set of all real values such that x, okay, because it fits between a range, we're going to put x in the middle. To the left, it's an open. To the right, it's closed, right? So we see that it goes to -3 to the left. We see that it goes to 1, 2, 3, 4, 5 to the right. Do we understand how the domain is found? Left and right. Okay, range. Don't ask me why, but they still use x instead of y here. So they say x is a set of all real values such that. Okay, you could put in y if you wanted to, but notice that y peaks at 10 and it bottoms out at 1, 2, 3, 4, 5. Right? So y is going to be less than or equal to, greater than or equal to, because it's a solid line, right? We don't have any dots there. So less than 10, greater than -5. Do we understand how those ranges work? Okay. Okay, these are all the same type of thing. Okay? Now, on here, my range it's going to be greater than or equal to -10, but less than or equal to positive infinity. Okay, because it continues to go up forever. The domain is the same way, right? It has a limit on the bottom end, but no limit on the top end. Okay, does that make sense? So we use infinities where it continues to go on that way. Okay? All right. I'm going to go on to, from here, we're going to go on to lesson 22. Do we feel like we understand some of this well enough? Okay. All right, let's pull up lesson 22. And I don't have this stuff in front of me, so give me a second while I pull out my notes. Okay. Okay, 22. A lot of this can be done in your calculator, which is handy for today's stuff because you don't have a lot of time. But it says graph the f of x equals the absolute value of x plus 4. Well, I don't know if you remember this from geometry or not, but the graph of an absolute value looks like this. Okay, because my y's always have to be positive. Right? No matter what my x value. My x value can be negative, but it's always going to come out as positive. And so this part, this y equals absolute value of x, is what we call the parent function. This part right here moves that function left or right, or I'm sorry, up or down. Okay, it moves it up or down. Now on this part of it, it works normally, which means if it says up, says positive, we move it up. So here, we're going to count 1, 2, 3, 4, and it's going to go like that. Okay? It's the same function, but it's been moved up on the y-axis 4 places. Okay? Now, just so that you're aware, if this had said f of x equals absolute value of x minus 4 plus 4, this is where it gets a little tricky because it's opposite of what you would think. You would think that that's going to move it to the left 4, right? Because it's minus. It actually moves it to the right. Well, not necessarily, because if it had said positive, it would have moved it 4 to the left. Okay? So when it's inside Whether it's when we deal with parent functions, when we move something inside with the x, the direction always goes opposite of the sign where it affects x, but it always goes with the y outside of that. Okay? A little weird. Can we get it? All right. All right, let's look at number 2. Okay, we've got g of x equals 1, 1 divided by 2 here. This is where, well, we could plug this in a table of values, but this is what I want you to be able to use your graphing calculator to look at these things. On a test question that involves these, you're going to have to give me a table of values and show me a rough sketch of the graph. Okay, but the table of values needs to be pretty thorough. So this is what you need to be careful. We're going to go to y equals, and we're going to type in 1 divided by, but the rest of this has to be in parentheses because I'm dividing by all of it. If I don't, I'll wind up with something very different and you'll get the wrong answer on the test. So from here, we need that absolute value. So we're going to type in math. We're going to go over to number. That gives me absolute value, x minus 3, close parentheses, minus 2. Now we're outside that absolute value. Close up the parentheses so that I have all of the denominator under that set. Now what I can do is hit graph, right? And that's what I should see. I should see a graph that looks like that. Okay? Do we get that? Did we practice it? We tried it? We get it? Okay. All right. Graph the following set on a real number line. A real number line. Let's see. Let's look at this. Trying to make some sense out of it. Okay. All right, so we have the absolute value of x plus 2 is greater than or equal to 5. So what we want to do with this is we want to solve it, but with absolute value we have to solve it twice. X plus 2 is greater than or equal to 5. Can anybody tell me what the second equation is? Close. You got the negative 5 part. No. You have to flip the sign and do the opposite. Okay? So as I subtract 2, right, I get x is greater than or equal to 3. Over here, subtract 2, x is less than or equal to negative 7. So negative 7, 3, right? They're closed circles on both. Okay? X is greater than 3, so I get an arrow going this way. X is less than negative 7, I get an arrow going that way. That's how I graph that on a number line. Okay, this is Algebra 2 stuff, right? This is not new. Okay, let's see, except it said 1 divided by, let's see, I don't guess hold on. No, where I'm sorry, I jumped up to number 2. We're looking at number 3. Okay, so let's look at number 4. Number 4, pretty much the same thing. I'm going to set that up as 2 equations because I don't need to isolate the absolute value. So I have x plus 1 what? Greater than or equal to 2. X plus 1 less than or equal to negative 2. So I get x is greater than or equal to 1. X is less than or equal to negative 3. Number line, I got 0. Negative 3, 1. Closed or open circles? Closed. Okay. Are these conjunctions or disjunctions? Are they going away from each other or towards each other? Okay, x is greater than 1, so goes that way. X is less than negative 3, goes that way. Okay? All right. On number 4, okay, let's see, I got about 8 minutes. Number 4, graph the following set on a real number line. Same basic type of thing. In fact, I'll just go ahead and give you, should be probably a disjunction, right? Same type of thing. Number 4, we should be, we are closed circles. So that should get rid of B for us, right? And C. And we should get D for our answer. Okay, just so that you're aware of that. Should get D. Okay? Did I get it wrong? Somebody's like got a smile. What's that? It's the one we just did. Was it the exact same? Oh, music. Oh, I did it, and I just didn't see that it was graphed. Okay. All right. Question number 5, sketch the graph of the function y equals 2 over x minus 1. What you can do with this, right, is do your x, y values. So if we do, like, let's say -3, -2, -1, 0, 1, 2, 3, that's usually a pretty good extent to take it. So 2, if I had -3 minus 1, that would give me what, -4? What's 2 divided by -4? -1/2, right? Okay. If I did -2, that would give me -3. I'd give me -2/3. Okay. If I had -1, that's 2 divided by what? -2. That'd give me -1. If I had 0, right, give me what? -2. Okay. 1 minus 1 would be 0. That's where I got a problem now, right? That's an error. Okay. That's what we would refer to as an asymptote. Why is that a problem? Because 1 minus 1 is 0, right? So I get that. So 2 minus 1 is 1. I get 2 again. I get just 2. And then 3 minus 1 is 2. 2 divided by 2, I'm getting 1 there. And I could graph those points, right? Okay, 5. What I should see whenever I go to graph this, okay, is something that's going to look like this. Okay, where we see that asymptote show up, really, the asymptote would show up about right there. Okay, that's where it goes off the rails. That's where I have that infinity error problem at. Okay? Okay. All right, 6. I think this is the last question. So if I've done this, I have made it. I have taught you everything in 2 lessons I did not intend to do. It says sketch the graph of each function. We should already know what that's going to look like, right? Because it's the parent function. Oh, I'm sorry. Yeah, that's a parent function. So it does this, correct? Okay, well, on this other one, it does something very different. Okay, should do something that looks like that. Okay, let's try it and see. Let's look in our graphing calculator. Okay, we want 1 divided by math, number, absolute value, x, close parentheses, graph. Okay, so I get something that looks like that. So very different things. So be careful with this stuff. Okay, just because your graphing calculator can do it doesn't mean that you're going to get the right answer. If you're not careful with how things are separated, if I'm dividing by an equation, that equation in the denominator needs to be in parentheses. If I'm dividing an equation, so I've got something up top, that entire top equation needs to be in parentheses. Otherwise, I'll only end up dividing by the last term in that equation. Okay? Let me stop here and then I'll answer your question.